Welcome! Let's learn how to define a part and run a detailed molding analysis in Inspire Mold. We'll be using the synctestmodel.xb file for this demonstration. If you'd like to follow along, please download the synctestmodel.zip file from the help, unzip it, then open the model in Inspire Mold. You can pause the video until you're ready. Since a detailed analysis isn't available in quick mode, let's ensure that we're in advanced mode before we begin. Now we need to define our part. We'll keep the default material. Next, we'll define our runner system, including gates, runners, sprue, and injection point. Here's a tip: you can also use the Auto Configure Components tool to save some time. Select the tool, then select the runner system's inlet. If your model includes a mold insert like this one does, you'll need to shift-click the insert to leave that part undefined, and then click the molding part to identify it. We'll define the mold insert later in the process. After we've defined the part and its runner system, we need to set the mold's opening direction. Now let's create a mold cooling system and designate the part insert. Let's define our mold. If necessary, we can change its size, material, and initial temperature in the micro dialog, but we'll keep the defaults. Now let's add a cooling system. Use the micro dialog to determine whether it will use air or water as a cooling agent, set the coolant's temperature and flow rate, and define start and end times for the coolant flow. If you don't define the start and end times, coolant will flow throughout the casting process. You can also use the Designate Cooler tool to make a cooling system using existing geometry. Now we'll designate the mold insert. Click Designate Mold Insert and then select the undefined geometry. You can change the mold insert's material and initial temperature in the micro dialog. We'll use the defaults. Now let's check our machine settings in the molding window. When the molding window analysis is complete, select a point in the green area of the chart, then click Update Initial Values. This ensures that the detailed analysis will run successfully. Next, we'll define our process parameters. For our purposes, we'll keep the default settings. We're now ready to set up and run the analysis. In the Run Analysis window, we'll select every stage of the molding process: compute cycling, filling, packing, cooling, and warpage. If we were using a fibrous material, we could tell the solver to compute fiber orientation, but our material is not fibrous. Everything is ready. Now let's select Run to start the analysis. This may take some time, depending on how complex your model is. We'll skip the waiting and go right to the data. When the analysis is complete, click the green flag to open the Analysis Explorer and review the results. The results in the filling stage include velocity, filling time, temperature, mold temperature, flow front temperature, and others. You can use the controls at the bottom of your screen to animate the results. The packing stage shows results for sink marks, pressure, and others. the callout tool to view a results measurement at a specific point on the model. Click the callout icon, and then click a point on the model. When you animate the result, the callout will show changes in the data at that point. When reviewing the cooling results, it can be helpful to look at a cross-section of the model. Warpage results can be difficult to see at their actual size. You can use the Animation Settings menu to change the scale of the simulation. This exaggerates physical changes in the part over time and makes it easier to notice potential defects. Another way to enhance the warpage result visualization is to use the Displacement Reference tool. This creates a custom point of origin for the part. The point will remain in place, and the rest of the part will warp around it. Finally, you can use the Uniform Compensation field in the Uniform Compensation Displacement result to find the ideal isotropic increase in the mold cavity's size. Note that this tool applies uniform scaling only. If your part has uneven warpage, we recommend using the Compensated Geometry tool to generate your finished model. Thank you for watching. Remember to subscribe for more tips on getting the most out of your Altair products.